Welcome to Zoom Into a Career. This series is designed to introduce students to a culture of high achievement by interviewing industry professionals. I am Andrew Kohler, the Community Relations Coordinator here at Yelm Community Schools, and today we have Frank Hudik with us to share a little bit about his career in the U.S. Navy and his experience at Boeing. Before we get started, I'd like to remind you that this Zoom is recorded and will be posted on our website for future viewing. Welcome, Frank. Thanks for joining us today.
Thank you, and I'm really glad to be able to do this. It's awesome.
It's honestly really nice to be able to talk with people outside the office and you know stay in touch with friends. So I'm glad we have you. Can you tell us a little bit about yourself and when you joined the Navy and what you did?
Okay. Again, I'm very appreciative of being able to do this. So I grew up in New Jersey, did not graduate from Yelm High School. We grew up in a family of 6 kids, and my mom and dad, small house, middle-class family. My dad held 3 jobs when we were young just to afford all of the kids the opportunity to go to college, and all of us did for either 2 or 4 years or more. But it was tough on my parents back then. Realizing that my 2 younger siblings may not have the opportunity to go to college, it made me look around for alternatives to perhaps either scholarship or somehow work my way through college. As I got more senior in high school, I noticed that a lot of things interested me in the natural world and also man-made things. And the things that interest me, I just kind of wanted to figure out how they work, why they work, what they do. And I'll give you a couple of quick examples because there were actually things that intrigued me to take an engineering path, which I'll talk about in just a second. But if you look out your front window and you see a telephone pole and you see a big pen on it, that's a transformer. What does a transformer do? How does it work? And so things like that really interest me. I'm going to figure it out someday. How does a digital computer work? What causes the aurora borealis, and how come I can't hear it when the thing lights off up in Alaska? Okay, so just a couple of examples of things that kind of interested me in science and eventually an engineering career. Back to the schooling real quick. Again, trying to find a way to get myself through. The Navy interested me a little bit, and I talked to my dad and some other folks. And I became interested in applying for the United States Naval Academy. Like West Point, Annapolis graduates, a 4-year program, and the tuition is completely paid by the Navy, and then you pay it back by taking on a career in the Navy. At that time, Naval Academy graduation was worth about $400,000. It's probably more than that now. I don't know the current total cost for a 4-year education there. Doesn't matter really. But I went the engineering path. I was highly promoted at the Naval Academy. And in 1979, I graduated with a degree in electrical engineering. And Drew, I don't know if you have those pictures you can show or not.
Yeah. If you want to keep talking, I'm going to try and figure it out how to screen share.
Okay. So just to go back to Annapolis for a second, the Naval Academy, if you wanted to go there, you have to get an appointment by your either U.S. Senator, U.S. House of Representative, the Vice President, or the President of the United States. So I was fortunate enough to get an appointment by Harrison Williams, who was our U.S. representative back then in New Jersey. And so I was commissioned in 1979, Ensign, United States Navy. And my first tour was on a destroyer. The primary mission of a destroyer is to protect the carrier from submarine or air attack. And so I was stationed on the USS Henry B. Wilson. If you have the picture of the ship, Drew, that would be the best one.
So I'm pulling up the video or the picture of the destroyer, and that'll be
I'll pick up from there.
Let's see here. Can you see it?
Ken,
It's
I tried to
sideways.
rotate it for you. Maybe go in the center there and rotate it if you can. Just above the picture in the center, there's a rotation.
Yeah, here we go.
There you go. So you want me to pick up from there and continue, or?
Yeah, that'd be great.
Sorry about that. I have to connect my cell phone via the internet, and we're out here in God's country, so it doesn't always work. Okay, so just continue. I was assigned as anti-submarine warfare on the ship, DDG-7, USS Henry B. Wilson, and the job of the anti-submarine warfare is to employ all of the ship's sensors and weapon systems to protect not only the ship, but also the carrier battle group or allies, etc., from enemy submarine attack. What you see there in the picture is really cool. It's a live firing of a anti-submarine rocket, which is basically a rocket with a torpedo nose on it. It drops into the water, the torpedo detaches from the rocket, and it goes out and searches for a submarine. So the idea is you detect the submarine, you want to get him before he gets you. So you fire this ASROC, as we call it, and it goes out and attacks the enemy submarines. Okay.
How long would you be on one of these ships?
So a typical tour for an ensign is 2 years on the first ship, and then followed by a second tour on a similar ship for a year and a half, and that completes what's called division officer tour or junior officer tour. And then after you complete those 3.5 years, you're rotated to a shore assignment, which is good for your family. And you can go to school and get your master's degree or teach or various other things that a Navy short tour offers you. I decided to go on and advance my education, so I went on to get my master's degree in electrical engineering, again, all paid for by the Navy. Went to the United States postgraduate school in Monterey, California. Beautiful place to go, great place to go to school, very technical, and again, a great career choice, and really great for my family at the time. We had 2 little kids, so it was awesome.
And then how many years were you in the Navy?
So I retired in 2000, so basically 20 years in the Navy. Had various jobs, working in shipyards, the Systems Command, which did design work of missile systems and ships and submarines, communication systems. And so a variety of tours before I was able to retire. And in retrospect, it actually set me up for a follow-on tour at Boeing, which was great because I was able to continue my engineering path, but this time applying it on in the civilian sector instead of the military. In fact, if you'll show that next picture, it'd be great, of the airplanes.
Let me pull that up real quick. And this one.
There you go. So on the left is the retiring P-3 Orion. It's a propeller-driven airplane that stuck around for 50 years. It's a great airplane. And the reason I was hired from Boeing was my anti-submarine warfare background, my engineering background. And at the time, they were building a brand new airplane, which you see on the right, called the P-8 Poseidon. And that airplane is a 737 derivative. So the Boeing took a 737 commercial airplane, gutted it, put more powerful systems on there, again, for combat purposes, anti-submarine warfare purposes. And they put a bomb bay in there so it could actually carry weapons out to the war front, if you will. So my job at Boeing was I was assigned to help develop several systems, and I was hired by Boeing in 2005. There's 2 principal ways of detecting submarines, not to go into too much detail, but acoustically, which is basically listening, and by magnetic detection. So you can think of a submarine as a giant piece of metal, and if you had a metal detector, you would sweep it across the ground and detect that piece of metal. Hopefully you'd be a millionaire because you found a gold piece. Well, we fly real close to the surface of the ocean and hope to detect a big chunk of metal, meaning a submarine down there. And that was one of the systems I worked on. It's called a magnetic anomaly detector. And one of the really cool projects that I got to work on, besides the mother airplane, the P-8 itself, was a launchable unmanned air vehicle. So we take the airplane up in the air and launch this small unmanned air vehicle. You see it at the top of the picture there. We called it Mag Eagle. And basically, its job was to take that magnetic detector out and sweep along the ocean while the mothership could stay up at higher altitude. And there's advantages to doing that, both the low-level sweep with the sensor, as well as keeping the airplane up in the air, so we could perform other tasks while you're looking for a submarine. So it was extremely fortunate to happen into this research project. We worked under the funding of the Office of Naval Research, and Boeing. Of course, I was still a Boeing employee, but that was our contract mechanism. It was a great project to work on.
And did you say that that aircraft was unmanned?
The P-8 big 737 was not. It had a crew of about 10 people on it. The little second slide that you showed, that was an unmanned air vehicle that was dropped out to the belly or off of the wing of the P-8.
All right. And is there any major problem that you had to solve, or because you mentioned that you worked on this project to find submarines? What are some other kind of nuanced challenges that brought on?
So, great question. One of the things I was kind of weak on in my engineering career was magnetics. Magnetics is a kind of a strange science, the mixed science most of engineering is when you get into really technical work. So I had to learn a lot about magnetics, magnetic detection. So one of the problems with a metal airplane or any aircraft that has metal on it, like machinery or motors, communication system, anything that might have metal components, is it adds to what's called the magnetic noise signature of the airplane. So you can imagine one amphitheater with 1,000 people talking. You're trying to listen to one particular person who might be 100 feet away from you. So we have a similar problem with magnetics. The Earth's magnetic field is very, very noisy, and what we're trying to do is find a little tiny signature, the signature of that submarine, amongst all of that noise. So what we had to do is come up with some very novel schemes to quiet the magnetic noise of the airplane. And we actually we won a patent at Boeing to do that. And without getting into too much technicality, we developed a mu metal shield that was able to quiet down some of the components on the unmanned air vehicle so that we could see through those components that were noisy and still be out of the submarine. So it was a good challenge technically. We partnered with some other industry partners, and we developed mu metal shield and proved its effectiveness. So it was awesome, really fun project.
And what did it look like when you were doing that? Was it kind of a one-man show, or was it a huge team of people? How did the communication aspect work?
It was very good industry team, industry government, I should say, because we teamed with engineers from the Office of Naval Research, a company in Texas called Polyatomic, and then Boeing. I was stationed in the Seattle area at the time, working in Phantom Works. And so it was a good teaming effort, and most of the actual technical work was down in Texas. So I got to travel quite a bit, worked with some fantastic top-of-the-line engineers, a few of these folks are world renowned engineers, and we developed not only the airplane or the unmanned air vehicle, but also the shielding and the detector that basically all put together became a very good system.
And I guess what I'm trying to ask is, what are some things that when you entered the Navy as a young, good-looking young man, what are some of the things that you didn't expect and that you had to learn along the way?
So certainly in the science field, it was magnetics, because that's just the path it took. And I think another thing that probably is worth bringing here is leadership. All of the service academies are big on this, the military certainly in general. As you gain rank and you become a leader, not a manager, but a leader of people, you have to take care of those people. You got to learn how to push their buttons. The buttons are different for different people. And one of the things that I was told was, it actually rings a bell, is difference between managing and management and leadership is you manage things. You manage budgets, you manage things, you manage production lines. And the key difference is leadership is often challenged, particularly in military and particularly in a combat situation, is you're telling people to do what they don't really want to do. So you have to be able to lead them into combat, for example, and you have to have your faith and trust all along the way. I mean, it's something you have to build up over years, such that if you give them an order, they'll execute it without question, because they know that you're and their future is in the best interest of the, and in this case, United States of America, I guess, as a military person. So there's leadership aspects in the civilian sector as well. No less important. It's just a little bit different than being in combat.
And what are some important skills or training that you need to enter that career field? And kind of going back, and it sounded like you took a lot of what you learned from the military and took advantage of the opportunity to go back to school and get an education. What did that look like?
I'd say if I have one single piece of advice, it'd be to challenge yourself. If you're truly interested in science and engineering or physics, you have to challenge yourself. And it's a rough road. People are out partying at college, and you're studying. You're doing projects. You're working on lab experiments. And it's sometimes difficult, but if that's really and truly in your heart, you have to pursue that with a lot of vigor and give up a lot of things that you would normally not have to give up in college. I mean, college is those years where you're having fun, meeting people, and doing a lot of fun things. Sometimes we just had to sacrifice to keep our nose to the grindstone and into the books, I guess. So education was not easy for me. I had to work hard at it. Some people have, intellect far above mine. They were able to get through it a lot easier than me, but I had to work at it tough.
And what do you recommend students do now, whether they're still in high school or coming up on graduation? Is there any specific classes or trainings that you would recommend?
Not too late to start, but certainly mathematics is the absolute key to anything technical. And so pay attention, take the tough courses, challenge yourself. Calculus, engineering, mathematics, algebra. As you progress through the grade levels and then into college, they get even more difficult. But it's the backbone of engineering. You absolutely have to understand mathematics and be able to apply mathematics to be an engineer or a physicist, and likely the other sciences as well. But I can only tell you from my experience that mathematics was key. And I was fortunate to have had very good teachers along the way, instructors as we call them in the military, and they took the time out to explain things if you didn't understand it. So, as you're going along and you don't understand things, don't be afraid to ask for help. I mean, engineering is a career field of collaboration. and nobody, or very few, I should say, maybe Bill Gates, can invent things on their own. You collaborate. You know, you look at things from different aspects. You talk to people in different fields because they approach the same problem differently. And like I said, I met some fantastic people along the way that personally I would never forget.
Is there any specific skills or attributes that make people more employable, considering you've worked alongside, probably hundreds and maybe even thousands of men and women?
A good question. So technical company, Boeing, which is basically aerospace and electronics, absolutely engineering or physics are the, preferred education paths. But what's interesting there is senior leadership in Boeing, some of them are technical backgrounds, but some of them are just good leaders. And they're hired because they know how to lead people. And so they don't necessarily understand the mathematics level of solving equations or designing something, but they know how to hire, and they know how to coach, and they know how to get programs going that are technical. And so that's a good leadership is rolls all that into a single entity as you move up the ranks. Certainly on the civilian side, where you have business aspects to also consider.
In closing, is there any advice that you would have given yourself as a young kid?
I wish I'd have paid more attention to math. Also, I was more, in high school, I was more about, passing the test, getting a good grade if possible, because I knew I wanted to go to college, and then getting out and playing sports or doing stuff with my friends. So if you're really want to go the engineering or physics path or science path, keep your nose to the grindstone, and math is so important. So make sure you understand it and bring that in your bag of tricks when you go into college and apply for an engineering degree. It's not too soon to start.
That's awesome. Awesome advice. And is there anything else that you would like to add that we haven't talked about today?
Only that in the Hudik family is very important to me. My son is also graduated from college. He went to Washington State University, go Cougs, and he's currently serving as a damage control assistant on board USS Shiloh. It's a cruiser out of Japan, and that particular ship's job is to sit off of North Korea's coast and protect the United States from missile attack from North Korea. So again, all these engineering systems all have to come together, and I'm fortunate that he went into the Navy, and he's also serving there right now as we speak.
And how long has he been in there?
Been in for 4 years. He's been on 2 different ships, as I described before. You do 2 tours, so he's about 3/4 of the way through with his tour, second division officer tour. And then he will be assigned shore duty somewhere. He doesn't know yet where. And then he'll make a decision as to whether the Navy or pull the plug and look for a Boeing or some other company.
Yeah, and I just I'm always in awe of the opportunities that are presented through military and service, because you can go in and really not know exactly what you want to do, but you kind of find what you're good at and what your interests are, and are able to use resources to go back to school and further education. I think there's a lot of examples.
Quite often on their dime.
I'm sorry?
And quite often it's on their dime. So I got my 4-year degree, 2-year degree in a master's degree in engineering, and I actually also got a master's in business administration. All of it was paid for the Navy. I didn't have to pay a penny.
Such a good opportunity. Again,
Yes, it was.
Thank you so much for joining today. And I love these conversations. The last two, I interviewed a guy yesterday. His name is Mike. He also works at Boeing and had a very similar um, career path of, using that resource of the military and having the government pay for your education. Um, it's pretty cool. So again, thanks for taking the time and talking with us today.
My pleasure, and God bless America.